Hello, hi everyone, welcome back to the channel. So this is your Ramandeep Singh. Today we'll be solving this problem, linked list cycle. So in this problem we are given the head of a linked list and we have to determine if the linked list has a cycle in it, right? So what is a cycle in a linked list? So here we have our linked list. The last node of the linked list points to the previous one of the previous nodes of the linked list, then that forms a cycle. How we can detect this cycle, that's what we have to know, right? So let's see how we can do that. To do so, what we need to do is we need to take two pointers. The first pointer is f, the second pointer is s. Basically the algorithm which we are going to use here to solve this problem is called Floyd's cycle detection algorithm. So in this algorithm what we do is we use these two pointers. The slow pointer moves one step ahead like this, from first node to the second node to the third node to the fourth node and so on, while the fast pointer moves two steps ahead, from first to the third node, then from the third to the fifth node and so on. So what we will do is we'll start these two pointers from this head node and we'll make them run. So let's start from the node 1. So from this node we'll move to the second node. This is my slow pointer, so the slow pointer is here, so let's call s. While in the very first iteration the fast pointer will reach this point. Let's move to the next iteration. In the next iteration the fast will be 1 2, the fast will be here and the second will be here. Let's move to the third iteration. In the third iteration the second will be here, the fast will be here, again the fast will be here. So what we observe here, after a few iterations these two pointers are matching. That was only possible if we had this link here, right? If we had this link, that means we started fast from here, we moved to this node, then the fast pointer moved to this node, then the fast pointer moved to this node, and in that time the second pointer is standing at this point, right? Because 1 2 and then 1 2 and 3, in 3 iterations the fast pointer is here, 1 2 and 3, and in 3 iterations the second pointer is also here. So what does that mean? That means after a certain number of iterations, if we have a cycle, then these two pointers are going to meet, and that's how we're going to solve this problem. We'll use two pointers. We'll start from the head node and we move ahead, we move those two nodes in the given linked list and we check whether they meet at any point or not. When they meet at some point, then that means there is a cycle in the linked list. So let's see how we can do that. So here in this case, let's see how we can do that. So let's first to the slow, the head pointer. Now let's move this loop fast and slow and fast next, till why I'm doing this, because the fast pointer must not be null, the slow must not be null, and the next of the fast must not be null for make the move, because we have to move 2 points. Like from here, if I want to jump to the third node next to the next node, then I need to have at least this node, right? Why? Because let's say if we do not have this node, then what I will have when I move 2 steps ahead, I will end up with a null pointer, and that's allowed, but there is nothing next to the null pointer, so I at least need one more node, one more not non-null node after the node on which I am standing, right? So let's see. Slow is equals to slow next, fast is equals to fast next. So if at any point these two pointers are matching, if fast is equal to slow, then I'm going to return true. Otherwise you have to return false at the end of this function. So let's run this code. So let's submit it. Okay, that got accepted. So that was all we had to do. This is called Floyd algorithm to detect the cycle. I hope you understood the algorithm. In the very next video, I will be discussing the proof for this algorithm, the proof for the Floyd's algorithm. Stay in touch, stay tuned with me. I will see you soon in my next video. Till then, take care, bye bye, love you.